Hey y'all, today is March 8th and I'm going to go over your Topic 6 study guide, which is, hint, hint, wink, wink, very similar to your test. So grab your study guide and a pen or a pencil and let's get started. So directions say answer each question. That's what we're going to do. Now, number 1, a valid blank is one that is true about the population based on a representative blank. And I told you if you needed a little hint to look at page 333 in your Savvis packet. You will see this actual very definition on your test tomorrow. So, a valid inference is one that is true about the population based on a representative sample. A valid inference is one that is true about the population based on a representative sample. Now, I do want to mention a question like this in Savvis, where you have those blanks, you're going to have like a little drop-down menu. So in a way, it's kind of multiple choice. So hopefully you would be able to get this with a question set up that way. Let's move on to number 2. So Tommy surveys students in his band class about time spent playing music by students in his school. Is this a representative sample? Explain. Well, problems that I see here. He surveys students in his band class about time spent playing music. Well, students who take band likely play music more than other students. So is this a representative sample? I would say no. And I would say that exact reason. Students in band likely play music more than other students. Students in band likely played music more than other students, so it's not a representative sample. Okay, let's move on to B. To determine whether students want a new school mascot, Abby surveys every 25th student from an alphabetized list of students in the school. Will the survey results from this sample support a valid inference? Explain. Yes. And I would say yes because the students were randomly selected. And we also know that every student in the population had an equal chance of being selected. So let's move on now to number 3. A school principal wants to know what theme students prefer for Spirit Day. There are 120 students in 6th grade, 176 students in 7th grade, and 192 students in 8th grade. Select all the representative samples that can help the principal draw conclusions about the dress-up day. And we're told right here that we need to select 2. So I know that the population here is students in 6th, 7th, and 8th grade. So I need my samples to represent 6th, 7th, and 8th grade. So SGA officers. Well, usually the SGA officers are 7th and 8th graders because 6th graders are new to the school. So that does not work. The students in the 8th grade homerooms. Well, that excludes 6th and 7th grade, so nope. Students who attend the next basketball game. Now that could be a mix of students, but some students might not be able to go to a basketball game. They might have other commitments. They might not be able to get a ride. So that does not work. Not every student has an equal chance of being selected. Okay, so that leaves us with 2 options. So I'm hoping that these 2 both work out. 36 graders, 44 7th graders, and 48 8th graders. Now it specifically mentions 6th, 7th, and 8th, and I need that in my sample. But the numbers are different. So what is 120 divided by 30? Well, when I put that in my calculator, 120 divided by 30, I get 4. So I'm thinking that 30 is 1/4 of 120. Okay, so 120 divided by 4 then I know is 30. Okay, what is 176, because that's how many are in 7th grade, 176 divided by 4? I'm hoping that that's going to equal 44, but let's just double check. 176 divided by 4 is 44. Okay, I'm feeling good about this. So now I'm going to check 192. So 176 divided by 4 was 44. And now I'm going to check 192. And I'm going to divide that by 4. And I'm hoping I get 48. So 192 divided by 4. When I put that in my calculator, I do indeed get 48. So what this tells me is that that fourth option is 1/4 of all the students in each class. So yeah, that works. Okay, and the last one, the same number of students from each grade selected randomly with a random name picker. Well, that works too, because you could have 25 from each grade level. Okay, let's look at number 4. Which of the following survey methods is least likely to result in statistical bias? So in A, it says ask a random sample of your friends what their favorite restaurant is. Well, the problem here is friends. You're asking your friends. So that is going to result in statistical bias. B, asking all the 7th graders what teacher is the best. Well, I'm assuming because we're asking 7th graders that we're talking about at a middle school. So the teachers in the middle school are 6th, 7th, and 8th grade. And if we just ask the 7th graders, they don't even know the 8th grade teachers yet. So that's going to create some statistical bias. And C, ask a random sample of all students what they want to be when they grow up. Well, key words here that are good. Random sample, we like that. All students, so all students are included. So I'm thinking C is definitely a good answer, but let's just read D just to make sure. Ask every 5th person you see walk into the computer lab if they like computers. Well, would they be in the computer lab if they hated computers? Probably not. They probably wouldn't sign up for that class. So C is our correct answer. Okay. I'm actually just going to box the whole thing in, like so. Okay, let's move on to number 5. Stacy wants to start a business in her neighborhood. She decides to ask her neighbors what services they need. She asks all the neighbors who have children if they would prefer a window washing service or a babysitting service. So let's identify our population in number 5. So our population, well, she wants to start a business in her neighborhood. So the population would be people in her neighborhood. It wouldn't make sense to ask people 2 towns over because she's not looking to start a business there. She's looking to start a business in her neighborhood. So the population is people in her neighborhood. Okay? We would need the sample to mimic that, to be the same as that. So everyone in the neighborhood has an equal chance of being selected. So it says select all the reasons that Stacy's method of collecting data may generate results with statistical bias. And it tells us to select 2. So let's just look at that first option. She records everyone's answer on paper. Well, that's actually a really good thing to do so that you remember everyone's answer. So that's not going to result in statistical bias. She only asked about 2 specific services. Well, it did say that. She asked about window washing and babysitting. So we know that that's true, but does it create statistical bias? Let's read our other choices and come back to that one. Okay, she only asked neighbors with children. Well, it does tell us that. If we read, she asked all the neighbors who have children. And people who have children are probably likely to say babysitting. So it's probably going to skew their results, right? So I do think that that creates some statistical bias. She asked everyone the same question. Well, that's good practice, so that's not problematic at all. And she only asked people in her neighborhood. Well, people in her neighborhood are the population, so she doesn't need to ask people 2 towns over. So that leaves me only with that one that I put a star next to. She only asks about 2 specific services. So what's problematic about that? Well, there are so many other neighborhood businesses she could have started. She could have done a dog walking business or a lawn mowing business or a plant watering business, right? And she's not taking into account any of those other businesses that might have generated some good income for her. She might have made some good money off of some of those options. So I do think that it's problematic that she asked about 2 specific services. I think it would have been better for her to ask something along the lines of, what service could I provide for our neighborhood? Something like that, instead of asking specifically about 2 different things. Okay, let's move on to number 6. And number 6 has been confusing people all day, so put a star here. Mario compares random download time of movies from 3 different services using the table below. Which service provides the fastest mean downloading speed? Okay, so we've got to compare the mean for each of these. So we're going to start with the first option, Who Knew? So to calculate the mean, I first need to add up all of these numbers. So I'm going to put in my calculator 4.9 plus 4.7 plus 5.0 plus 4.6 plus 4.8. And when I put that into my calculator, I get 24. Now that's my sum. So I'm going to divide that by the number of terms. And there's 1, 2, 3, 4, 5 terms. So I'm dividing 24 by 5. And 24 divided by 5, if I put that into my calculator, I get 4.8. Okay, let's do the same thing for the next service, Amazing Prime. So I'm going to add up all of those terms. So 4.6 plus 4.6 plus 4.8 plus 4.6 plus 4.9. And when I add those up, I get 23.5. So 23.5. And I still have 5 things, so I'm going to divide by 5. 23.5 divided by 5 is 4.7. Okay, let's keep going. Our last service, Preach TV. So I'm going to add up all of my terms. So we have 4.9 plus 4.9 plus 5.1 plus 5 plus 5.1. And when I add those all up, I get 25. Now 25 divided by 5 is 5. So I'm comparing my mean downloading speeds, 4.8, 4.7, and 5. Okay, and I want to know which one is fastest, but I want to point something out. Notice our download time is measured in megabits per second. It's not measured in time in minutes, it's megabits per second. And I don't know a whole lot about downloading, but I would assume that you want all the megabits to be downloaded. And the sooner that all the megabits are downloaded, the sooner that you can enjoy the movie or the song or whatever it is that you downloaded, right? So what this first one is saying is that with Who Knew, it's downloading 4.8 megabits in 1 second. For Amazing Prime, it's downloading 4.7 megabits in 1 second. And for Preach TV, it's downloading 5 megabits in 1 second. So, which one downloads the most megabits per second? So I'm even going to write that. Which service downloads the most megabits per second? Well, the most megabits per second is this one right here, that 5. 5 megabits per second is more than 4.7 megabits per second and more than 4.8 megabits per second. So which service provides the fastest mean downloading speed? Preach TV. And that right there is my answer. Okay, let's move on to number 7. So the dot plot shows a random sample of the number of migrating geese flocks observed by 25 participants during a 2-day hike. Use the mean value of each data set to make an inference about the number of flocks observed each day. Well, I'm just going to start by making an inference, and then I'll find my mean and see if my mean supports my inference. Okay? So one thing that I notice right off the bat is that I have a lot of data here at 6 and 7 in day 1. And I have no data here at 6 and 7 for day 2. So it's like for day 1, all of my data is further to the right on my number line than it is for day 2. So I'm guessing that they observed more flocks on day 1 than day 2. Now, another way that I could phrase that same thing is they observed fewer flocks on day 2 than on day 1. That's the same thing as what I just wrote, okay? So be mindful of what you wrote. Sometimes we can have the same thing. It can mean the exact same thing, but be worded a little bit different. Now, let's actually calculate the means. So let's start with day 1. Okay, the way I calculate the means is I do it by columns. So 4 times 4 is 16. 5 times 7 is 35. 6 times 7 is 42. And 7 times 7 is 49. So when I add up 16 plus 35 plus 42 plus 49, I get 142. And I divide that by the number of dots. And I could count up the dots, but I also know that there were 25 participants. So 25. 142 divided by 25 is 5.68. Okay? Now let's calculate the mean for day 2. Okay? So for day 2, again, I like to count by columns. So I've got 8 dots in this first column. 8 times 2 is 16. 7 times 3 is 21. 6 times 4 is 24. And 5 times 4 is 20. So when I add up 16 plus 21 plus 24 plus 20, I get 81. And I divide that by the number of dots, which is still 25. And 81 divided by 25 is 3.24. Okay, so which day has a greater mean, a bigger mean? Well, day 1. And didn't we say that they observed more flocks on day 1? We sure did. So my means do indeed support this inference that I made. So I feel good about that. Okay. Let's move on to number 8. Harry collects data from a random sample of 7th graders. Out of 25 respondents, 10 ride the bus to school. Of the 150 7th graders who attend Harry's school, how many would be expected to ride the bus to school? Okay, important information here. There are 25 survey respondents. 10 of them ride the bus. There are 150 total 7th graders. So, how am I going to find my missing value? How can I figure out how many would be expected to ride the bus to school? Well, I'm going to write a proportion and solve it. So a proportion is 2 fractions set equal to each other. My first fraction, I'm going to use my survey results. So 10 out of 25 say that they ride the bus to school. So 10 over 25. And that equals something. And I need a variable and I need a 150. So where does the 150 go? Well, if you remember that the top is the part and the bottom is the whole, that'll tell you where the 150 goes. 150 is the total number of 7th graders. So it is the whole number. So 150 goes on the bottom, and that means that x goes on the top. And we're solving for x. So now we're going to cross multiply. So 25 times x is simply 25x, and I set that equal to 10 times 150, which is 1,500. Now to get that x by itself, I'm going to divide by 25 on both sides. So divide by 25, my 25s cancel out. X is by itself. 1,500 divided by 25 equals 60. So in my box, I would just write 60 seventh graders. Okay, moving on to number 9. Bryson surveyed a representative sample of students at his school to collect data about their favorite book genre. Do we know how many people he surveyed? No, but I can figure it out from my table because I can add these numbers up. So 5 plus 12 plus 28. When I put that into my calculator, I get 45. So I know that he surveyed 45 people. Okay? Now it says estimate how many of the 450 students who attend Bryson School prefer to read fantasy novels. So again, I'm going to write and solve a proportion here. So, how many of the people surveyed prefer to read fantasy novels? Well, 12. So, 12 out of 45. That's the survey results. And I want to set that equal to another fraction. Well, what goes in that fraction? I know I'm going to have a variable, but what number? Well, it says estimate how many of the 450 students in his school. So, 450, is that the part or the whole? It's the whole, so it goes on the bottom. So 450 on the bottom, we're going to put x on top. And now we cross multiply. So 45 times x is 45. X equals 12 times 450. If I put that into my calculator, I get 5,400. Now to get that x by itself, I'm going to divide by 45 on both sides. So my 45s cancel out. X is by itself. What does x equal? Well, it equals 120. 120 students. Okay, moving on to number 10. It's a similar, or it's really the same situation. Bryson surveyed a representative sample of students at his school to collect data about their favorite book genre. Bryson wants to know what book genres are preferred by people in his town. Can he use his sample data to form a valid inference about the town? Okay, so I just want to point out the sample of students at his school. So the sample is students at school. Okay, but Bryson wants to know what book genres are preferred by people in his town. Well, what is people in his town? That's the population. So the population now is people in town. So my question to you is, does my sample match my population? Think of it as this way. My sample is students at school. It's like a bunch of kids. And my population is people in town. It includes kids and adults. So my sample, because it's just kids, is leaving out all the adults that could be in town. So can he use his sample data to form a valid inference about people in the town? No, he cannot. Okay, and here's what we could say. He cannot use his sample data to form a valid inference because his school does not represent the town's population. He cannot use his sample data to form a valid inference because his school does not represent the town's population. I forgot my word because, so let's just add it right there. Okay? let's move on to number 11. I want you to put a star next to this one because a lot of people have been confused by this one all day as well. The box plots show the amount of time farmers from 2 farms spent harvesting crops over the past 2 months. What might you conclude about the harvest based on the interquartile range, or IQR? Okay, so we have to understand what that is. And we know that interquartile range refers to the length of the box. Okay, so there's a formula to calculate it. That formula is Q3 minus Q1. Okay, now, just looking, I would guess that farm 2 has more variability. The box looks longer, but let's just verify that. Okay, so let's start with farm 1. Okay, so remember, Q3 is the back edge of the box. So Q3 is right here at 36. Q1 is the front edge of the box, right there at 28. So 36 minus 28 is 8. Okay, that's my interquartile range for farm 1. Now let's talk about the interquartile range for farm 2. So Q3 is the back edge of the box. It's right there at 43. Q1 is the front edge of the box at 37. So 43 minus 37. When I put that into my calculator, I get 6. So, based on the interquartile ranges, 6 and 8, which farm has greater variability? Well, farm 1. So I'm even going to write that. Greater variability. That means that farm 2 has less variability. Okay, now I do want to point out some of these answer choices. So let's look at A. The crops on farm 1 and farm 2 become ready for harvesting on a consistent basis. That means they're equal. They're the same. Are they the same? Nope. So I know that A is not the correct choice. So it's down to either B or C. Okay, and they use this phrase in there, more consistent, more consistent. So consistency is related to variability. And I want to give you an example of consistency. So when I go work out, I do a CrossFit style workout. And let's say that in one of my workouts, it is in a 3-minute window, complete as many reps as possible. And we're going to do that 5 times. Okay, let's say the first round I get 18 reps. Okay, so to be consistent, how many reps do I need for the second round? Well, I need 18. To stay consistent, how many reps do I need for the third round? 18. You see where this is going, right? In the fourth round, to stay consistent, how many reps do I need? 18. And lastly, in the 5th round, if I still want to be consistent, how many reps do I need? 18. So if this was a data set, what kind of variability do I have? I have no variability. So it's very 100% consistent, right? Okay, so the less variability, the more consistent, or the more consistency. The less variability, the more consistency. So we said that farm 2 had less variability. That means that there is more consistency. Okay, we said that farm 1 had greater variability. More variability means that there is less consistency. Okay, so let's read our answer choices. So the crops on farm 2 become ready for harvesting on a more consistent basis than the crops on farm 1. Well, we just said farm 2 had more consistency. So B is the correct answer. Okay, so let's move on move on to the next page to number 12. So Carrie is comparing the growth of plants under natural and artificial light sources. So we've got group P and group Q. And in part A, it says, use the measures of center from the box plots to make an inference about the data. Now, measures of center. There are two measures of center, mean and median. But the only one that we see in a box plot is median. So I have to compare the medians. Now this part A will be multiple choice on your test, and you will have two answers that say based on the means. Well, we don't know the means, so you need to eliminate those two answers. Focus on the two that say based on the median, and then choose the correct one from that, okay? So we're looking at our medians, and our median is the line that divides the box into two sections. So my median for group P is right there. If I draw that line down, it's at 2. And my median for group Q is right there. If I draw that line down, it's at 3.5. So which one is greater? Group Q, right? So I'm going to say based on the median, the plants in group Q grew taller than the plants in group P. So I know that they grew taller in group Q because the median is further to the right on the number line. So 3.5 is much bigger than 2. So these plants in group Q grew taller. Okay, now let's look at B. Use the box plots to make an inference about the variability of the data. So when I'm looking at a box plot, I see two measures of variability. I see the IQR and the range. So I can compare those two things. So let's just make some notes up here, and let's start with group P. And let's start with the range. So the range, to find the range, I take the maximum and I subtract the minimum. So the maximum is the back edge of the box plot. So if I draw a line down, that's at 3.5. So 3.5, and I'm subtracting the minimum, the front edge right here. And if I draw a line down, that's at 1. So 3.5 minus 1 is 2.5. Now let's look at the IQR for group P. So the IQR is the length of the box. So let's start at Q3. Q3 is right there at 3. And I'm going to subtract Q1 from that, right there, the front of the box, 1.5. So 3 minus 1.5 is 1.5. Okay, so let's now do the same thing for group Q. So we'll start with the range, the length of the whole box and whisker plot. So I'm going to start with my maximum, 5, and I'm going to subtract my minimum, 2.5, from that. So 5 minus 2.5 is indeed 2.5. Now let's look at the IQR. So the length of the box. So starting with Q3, 4.5 minus 3. So 4.5 minus 3 is indeed 1.5. So let's compare these. Well, the range for both is 2.5, right? And the IQR for both is 1.5. So my range and IQR are the same. So the range and IQR are the same in group P as compared to group Q. So there is what kind of variability? I can't say there's more or less. So I'm going to say there is similar variability in the growth of the plants in both groups. Okay, let's move on to number 13. Put a star next to number 13. You need to know this. This will be a select all that apply. It says list the measures of variability that can be used to compare two or more data sets. There are 3 measures of variability. and you need to know what these three are. This will be on your test. So range is one. IQR, interquartile range, is the second one, and mean absolute deviation, or MAD, is the third one. Okay, you also need to know number 14. List the measures of center that can be used to compare two data sets. Okay, well, measures of center, there are two of them. They are mean and median. Mean and median are measures of center. Range, interquartile range, and mean absolute deviation are measures of variability. Okay, let's move on to number 15. Andy is comparing how long two tablets can be used after being fully charged. Okay, so part A, use measures of center to make an inference about the data. So we're looking at measures of center here. So measures of center, we've already established are mean and median, right? Well, those are both in my table. So mean and median are right here. So I'm comparing those first two rows. Well, one thing I noticed right off the bat is that 593 is bigger than 540, and that 589 is bigger than 560. So I'm noticing that these two for tablet B are bigger than their same measures for tablet A. So I'm going to say that tablet B can be used longer than tablet A after being fully charged. Tablet B can be used longer than tablet A after being fully charged. Okay, let's move on to part B. Based on the data, which tablet performs more consistently? Well, we talked about this in number 11, more consistently. Well, that means that there is less variability. So now I'm looking at measures of variability. So we're back at our table. Measures of variability. Well, those would be the IQR and the mean absolute deviation. So now I'm comparing these two things. And one thing I notice is that 21 is bigger than 13 and 6 is bigger than 2. That means these numbers are bigger for tablet A than their same numbers for tablet B. Okay, well, the greater the number, the more variability there is. And that means there's less consistency. So I actually want to look at the smaller numbers. So these numbers for tablet B are smaller. That means tablet B performs more consistently because there's less variability. Okay, so based on the data, which tablet performs more consistently? Tablet B. And we're going to say because the measures of variability are smaller. So when there's less variability, there's more consistency. Okay, let's look at our last question. So our last question, number 16, Zach recorded the number of miles that two of his friends ran each day. Part A, identify the mean absolute deviation for both runners. So I'm going to look for this to be a very small number. So if anything's a big number, I can eliminate it. Okay? Now, let's start first with Jack. We're going to calculate the mean. So I'm going to add up 4 plus 5 plus 2 plus 6 plus 3. When I add that all up, I get 20. Okay, so now I'm going to take 20 and I'm going to divide by the number of terms. There are 5. 20 divided by 5 is 4. That's the mean. I know that that's small, but that's the mean. Okay, my mean absolute deviation will be even smaller than that. So now I'm going to write the data for Jack in a vertical line. So I have 4 5, 2, 6, and 3. And I'm going to subtract 4 from each one of these. Okay, 4 minus 4 is 0. 5 minus 4 is 1. 2 minus 4 is negative 2. 6 minus 4 is positive 2. And 3 minus 4 is negative 1. So I'm actually going to take these numbers and make them all positive. So we have 0, 1, 2, 2, and 1. And now with that new data, I'm going to add them up. Well, when I add that up, I got 3 here plus 3 here. I got 6. So 6, and I'm going to divide that by 5. And 6 divided by 5 is 1.2. So 1.2. That is my MAD for my first runner, Jack. The MAD for Jack is 1.2. Now we're going to do the same thing for Randy. So first thing I'm going to do, add all these numbers up. 10 plus 8 plus 9 plus 9 plus 11. When I add that up, I get 47. So 47 divided by 5 will give me my mean. And when I put that into my calculator, I get 9.4. So that right there is not my mean absolute deviation, that's my mean. And I'm going to look for my MAD to be smaller than that. Okay? So now I'm going to write Randy's data in a vertical line over here. We have 10, 8, 9, 9, and 11. And I'm going to subtract 9.4 from each of these. Okay, so 10 minus 9.4 is 0.6. 8 minus 9.4 is negative 1.4. 9 minus 9.4 is negative 0.4. 9 minus 9.4 again is also negative 0.4. And 11 minus 9.4 is going to be 1.6. So now I'm going to take all these numbers here and I'm going to rewrite them so that they're positive. So we have 0.6, 1.4, 0.4, 0.4, and 1.6. And I'm going to add them up. So when I add those up, I get 4.4. 4.4. And I'm going to divide by the number of terms, 5. And when I put that into my calculator, I get 0.88. So that right there is the MAD for Randy. So 0.88. So we've calculated the MAD for both runners. So part B, complete the statement. Blank has greater variability. Well, who has greater variability? Jack. So Jack has greater variability in distance run because the value of the MAD is greater or larger. Any of those words will work. That is the end of our study guide review. Study for your test today and have a great day.